Hey, if you are in high school or college and you're currently taking Physics 1, then this video is for you. So, after tutoring hundreds of students myself, I've noticed that the topic of one dimensional kinematics has caused trouble for a lot of people. So, I'm going to go over an easy strategy that you can use to solve any one dimensional kinematics problem in this video. So, first off, let me review the main equations that we're going to need to solve any of these problems. So the first one, final velocity equals initial velocity plus acceleration times time. Sometimes, depending on your course, you might see initial velocity as VI. So if that's what you're used to, then it's the exact same thing. Second equation, V final square equals V initial square plus 2 times acceleration times displacement. Third equation is displacement equals v initial times time plus 1/2 acceleration times squared. Next one is displacement equals initial velocity plus final velocity divided by 2 multiplied by time. So these are the four equations that we're going to use to be able to solve any one-dimensional kinematics problem. So basically in each one of these equations, the most important thing is to notice is that each one is missing one of the main variables, meaning that equation is independent of it. So let's take a look at this first equation. It's independent of displacement. The second one is independent of time. The third one is independent of the final velocity. And our last equation is independent of the acceleration. And when we get to solving problems, I'll share why this is important. So let's get right into solving some example problems. So I have a worksheet pulled up in my other tab. All right, problem 1. A runner accelerates to 4.2 meters per second square for 10 seconds before winning the race. How far did he or she run? So the first thing we have to do is make a list of variables. Always start every problem by making a list of what variables we have. So let me write down the 5 main variables: v initial, v final, acceleration, displacement, and time. So what did we get in the problem? In the problem, they said acceleration is 4.2 meters per second square. Let's write that down. The time is 10 seconds. And we can assume by the problem that the runner started from rest. So we can say the initial velocity is 0 meters per second. And what are we trying to solve for? We are trying to solve for how far did they run, which is the displacement. So now that we've made this list, we can see out of all the variables, the only one that's missing is this final velocity. So based on whichever variable is missing, that tells us which equation to use. So we can see that in this case, this third equation that's independent of the final velocity would be the correct one to use. So now we can just plug in the values into our equation. So displacement equals v initial times time plus 1/2 acceleration times squared. So that would equal v initial is 0 times 10 plus 1/2 times 4.2 times 10 squared. This is 0 times 10. This would just cancel out because it's 0. So we're left with 1 half times 4.2 times 10 squared, which is 100, which would give us 1 half times 4.2 is 2.1 times 100 is 210 meters. And that is our final answer. Let's go on to the next problem from that same sheet. At this point in the video, feel free to pause and try solving this problem on your own, and then you can come back and see if you were able to get the right answer. So let's go into this one. Plane starts from rest and accelerates uniformly over a time of 20 seconds for a distance of 300 meters. Determine the plane's acceleration. So again, we follow the same exact process. Again, we make that same list of variables: v initial, v final, acceleration, displacement, and time. So we got starts from rest. That tells us that the initial velocity was 0 over a time of 20 seconds for a distance of 300 meters. So time is 20 seconds and the displacement is 300 meters. And here we need to solve for acceleration. Again, just like the previous problem, final velocity is the one missing. So we would again use that third equation. Plus 1 half acceleration times squared. Let's plug in our values. 300 equals 0 times 20 plus 1 half acceleration times 20 squared. 0 times 20, we can cross that out. So we're left with 300 equals 1 half times acceleration times 20 squared is 400. So now it's just algebra from here. We just need to solve for acceleration. So we can multiply both sides by 2. We get acceleration times 400 equals 2 times 300 is 600. And now we just divide both sides by 400. Acceleration equals 600 divided by 400. Zeros cancel out. We get 6 divided by 4, which is 1.5 meters per second squared. All right, here, let's do one last problem. Let me erase this. All right. So again, at this point in the video, feel free to pause and try solving this third problem on your own. All right, problem 3. A ball free falls from the top of the roof for 5 seconds. How far did it fall? And what is its final velocity at the end of 5 seconds? So again, we can say that the initial velocity was 0 meters per second. 5 seconds. The time is 5 seconds. So the other keyword is in this problem is free fall. Anytime a problem says free fall, that means the acceleration is just the acceleration due to gravity, which is 9.81 meters per second square. So the first part of the problem is asking how far did it fall? So it wants the displacement. So again, we use this third equation. Displacement equals 0 times 5 plus 1 half times 9.81 times 5 squared. This cancels out. And then let me just plug this into my calculator. So we have 0.5 times 9.81 times 5 squared, which is 25, giving us 122.625. We can round that to 123 meters. And then the second part of the problem is asking what is its final velocity at the end of this time frame. So for the second part, since we've actually have all the variables now except for final velocity, we could really use any of these formulas. I'll just use the first one in this case just because it has v final by itself, so it'll be the easiest use in this situation. So we have final velocity equals initial velocity 0 plus acceleration times time, 9.81 times 5, giving us our final answer of 49 meters per second. That's all for this video. I hope that it helped. If you have any other topics that you need help with, feel free to drop it in the comments. And if this video helped, please do like and share with someone else. Have a great day, everyone.